everyone, welcome back. In this particular video, we will be discussing the problem named find single number. You are given a non-empty array of integers. Non-empty array means array having at least one element, that is size is at least greater than equal to 1, where every element appears twice except for one element. That is, in the entire array, every element is occurring two number of times. The frequency of each element is 2 except for one element, and for one except element, that is a single element, that occurrence will be only one. We can assume it because the question number is find single number. Your task is to implement a program that takes the input as an array of integers and returns the element that appears only once. So all the elements appears twice except the single element which occurs only once, that is frequency is only 1, and we have to find that single occurrence only. So input format will be, of course, the number of elements first of all, that is the array size, and then all the array elements, which will be in the range from -3 times 10 raised power 4 till plus 3 times 10 raised power 4. That is almost integers, both in negative and positive will be there. And a very important note which is mentioned here is you should use a hash map based solution to efficiently identify the element that appears only once in the array. There will be solutions which are better than hash map, but for now we will be discussing them as a part of follow up. We will not code them because for them we require some extra knowledge which we will be learning after hash map, which is actually based on some mathematics. But even before discussing actually the hash map based solution, we will start with a very brute force approach. So what is the example? Let's take a bigger example. This is a very basic one where there are only three elements in which two is repeating two times, one is not repeating. So one is the answer. How about this particular array? Two repeating two times, three repeating two times, one not repeating, four repeating two times. So one is the answer. But it is not necessary that all the repeated elements, the repetition will occur at consecutive indices. In these two examples, you might think that the repeated elements will just come at I and I plus one index. But it is not true because nothing is mentioned in the problem description. So we can't assume anything. And also we can't assume that all of the elements will be in increasing order or ascending order, anything. They will be in any random order, like the way it is in the second example, 2, 3, 1, 4. So let's take another test case, which we are saying is nothing but having values 20, then let's say 40, then let's say 50, let's say 40, let's say 20, let's say maybe the element is 60, and let's say the element is, you can say, 50. So this is the array which is given to you, and you need to find the element which only occurs once, except that all the other elements except that answer will occur twice. So as you can see, 20 is occurring twice, so 20 is not the answer. 40 is occurring twice, 40 is not the answer. Even for that matter, 50 is occurring twice, so 50 is not the answer. Let's say the answer is not 60, but it is 30. Just to let you know that it might not be the maximum. So I am taking 30. So you can say 30 will be the answer because it is only occurring once. But the point is, how will you find this answer? Let me just undo all of this. A very brute force approach where you are not taking any data structure, you are not basically doing any kind of optimizations, will be just to find which element is not repeating. That is, first you will ask 20. Is the 20 occurring again in the remaining array? If it is occurring again in the remaining array, then it is not the answer. So I will run a loop over the remaining elements, that is after the current index. If let's say the outer loop variable is I will run an inner loop variable which is day, starting from I plus 1, going till the last index, and check if any other element is equals to I or not. So right now, there is no more element which is equals to 20. And even for that matter, you should not actually run for I plus 1, because otherwise what will you get is, let's say if you are standing on this particular ith index, then you will say that is there any other I after, is there any index after this ith index, which is fourth index, which is having value 20, and you will say no, there is no index. So you will return 20. So instead of just running the inner loop after the current index, what you can do is better to run a loop which is inner loop also over the entire array. That is, you will run the jth loop also over the entire array, just skipping the same index. You should not just compare array of I with array of j when both I and j are 0th index only. So you will start it from 0 and you will check, is there any more index having value 20? And you are saying that yes, there is a pair which is 20. Now let's try for the next index. Maybe the next index is the answer, the element present at the next index. So I will say the ith index will get incremented, but now again jth pointer will start from 0th index because the repeated element can be previous to it, can be after it. So is this 40? No. Is this 40? Yes, but do not consider the same index. So skip it. Is this 40? No. Is this 40? Yes. So 40 is also repeating. It is not the answer. Then try for 50. So what you will do for 50? You will say index plus plus I, the outer variable, the outer loop. And after making it incremented, you will start j again from the 0th index, except the second index where I is currently at. You will check is there any other index also having the element. So what is the time complexity which is going to take for this kind of nested loop approach? We are saying outer loop is also going to work for the on n elements. In worst case, it might happen that the single element occurs at the last index, and the inner loop is also going to work for n times, that is the entire array. So it is n into n, or you can say n square, that is quadratic time. However, if we don't want a extra space, then this is a good solution. Why? Because it is using constant extra space, no extra data structure as such. We are just maintaining two pointers I and j, and that's it. But the point is, can we do better? Answer is yes. Since there is no ordering right now among the elements, how about if we order all the elements, maybe in ascending order, or you can say increasing order? We can easily ascend all the elements. We can make them sorted in increasing order by using some inbuilt sort functions. Maybe it might use merge sort, quick sort. We don't know which sorting it will take internally, but given that it will sort all the elements in n log n time, which is the best possible time complexity for most of the sorting algorithms, which are there as inbuilt sortings. What you will do is you will just rearrange all these elements as first 20, next also 20, then it will be 30, then it will be 40, 40, then it will be 50, 50. Let's say the element 30 was not the answer. Let's say 40 was the answer. So what will you say is all the repeated elements will be occurring consecutively. All the repeated elements will be occurring consecutively. So what you can do is you can just check whether the element is same at the previous index and the next index. If it is not present at the previous index as well as the next index, then it is the answer. Like the way 20, are you single occurrence? No, 20 is also present at next index. 20, are you single occurrence? No, it is present at the previous index. Or what you can do is you can also just go to even indices if you want. So ask to 30, are you a single occurrence? Yeah, no, because it is present at next index also. And in this way, you will be able to find the answer for 40, because when you will ask for 40, it is not present at next index. But what will happen if, let's say, we are doing sorting? It will take n log n time, but we will be able to do it still in constant space, provided that the sorting used is a in place sorting. That is, it does not take extra space. But still there is a scope of improvement, and the scope of improvement, when we say, is by using the trade-off that if we still want to reduce the time complexity, we can actually use some extra space. And how will we actually use some extra space? That we are going to do using a key value pair data structure. That is what we need to store. We need to store for every element how many times it is occurring, the element corresponding to the element, the frequency of it, that is key and value, a pair of it. And we want all the keys to be unique. Basically, we don't want 2 times 20 should occur. We want such a data structure where 20 should occur only once, and it should tell me the frequency of it. 40 corresponding to the frequency, 50 having some frequency. And once that entire data structure, that key value pair data structure is built, what we will do is we will find such element, such key whose value, whose frequency, whose number of occurrences are only one. And that data structure is nothing but a hash map, or you can say it is nothing but a map in general. So what we will do is, instead of maintaining two pointers, instead of sorting, just create an extra data structure where both key and value will be integers, because both are elements and frequency of that element. Initially, it will be empty. The hash map will be completely empty, zero size. You will start iterating over the array, because that is how you will fill the hash map with the frequency of elements. 20 right now is having zero frequency. So put the new frequency as old frequency plus one, that is 0 plus 1. Because if it is occurring for the first time, you will take the old frequency as 0 and put the new frequency, or insert the new frequency as 1. Similarly for 40, since it is not there right now, you will put the new frequency as 0 plus 1. 50, since it is getting inserted for the first time, 0 plus 1. But now 40, since it is getting inserted for the second time, Get the old frequency from hash map itself. No need to go anywhere. No need to again run a nested loop. Just check the hash map. Since 40 is already present, get the frequency of it. In hash map, you can get a frequency or you can put a key value pair in constant time average case. So you will get it in constant time. In average case, the frequency is 1 and you will update it with 2. That is put again the same key, because whenever we put a key again in a hash map, it does not insert two keys with same values, but it will do what? It will just update the value of the same key itself, that is same pair itself. There will be no two pairs having same keys. It is a very important property of hash map. You should learn it, that all the keys in a hash map are always unique. So that's why in the same key of 40, it will just update the frequency as 2. Then going to 20, what it will happen? We will say update the frequency as 1 plus 1. Take the old frequency, add 1 in it. For 30, take the old frequency. Since it is not present, we should take the old frequency as 0 and put the new frequency as 0 plus 1. And finally, for 50, you will say old frequency is 1, take the new frequency as 1 plus 1. Now you can run a for each loop over the elements in the hash map. No need to run the loop again on array. If you want, you can run it, but better will be to run a loop over hash map only, because it will have less number of elements, almost half number of elements. Why? Because the elements which are repeated in the first array or the input array, they will not be repeated in the hash map. So is a 20, is it a single occurrence? No, it is having two occurrences. It is not the answer. Is 40 the answer? No, it is having two occurrences. Is 50 the answer? No, it is having two occurrences. Is 30 the answer? Yes, it is only having single occurrence. So using the hash map or using the key value pair data structure, we will be able to do it in even lesser time. And what will be the time complexity associated with it? We will say, since we are first running a loop over the array of n size and inserting all the key value pairs in the hash map, insertion will be constant, but running a loop over the array will be linear in nature of order of n, where n is the size of the array. And then running a loop over the hash map also will be order of n by 2 in worst case, which is still n only. So n plus n by 2, it is still linear. But since we are using a hash map, since it is about to store almost half of the size of the array, so space complexity is used, extra data structure is used, auxiliary data structure, which is a hash map of linear size. So linear time, linear space complexity, that is, there is a trade-off which we are right now choosing, time over space. We are optimizing time from n log n to n by using some extra space, by compromising with space, that is taking linear space. So what we will do is we will write the instruction manual for the hash map based solution only. We will be discussing this only. But just as a follow-up, I am discussing one more approach, given that you know about bit manipulation, given that you know at least about the XOR operation. So there is a fourth solution also existing for this problem, which is even better than the hash map based solution. And what is that? If you know a property of XOR, that A XOR A will always give you 0. That is, if you will XOR something with itself, it will always give you 0 value. And there is one more property. If you will XOR 0 with something, it will give you that same thing. That is, 0 XOR A will always give you A. Given these two properties, you will be able to also answer this problem using XOR. That is, initialize a XOR value with a 0, start a XOR value with 0, and take XOR of all the array elements in this XOR variable. That is, first take XOR of 0 with a 20. So XOR is usually represented like this. Right now I'm discussing a follow-up based solution, which you can try to explore on your own. But right now I'm just discussing the approach. Then go to 40, take the XOR in the answer, that is the XOR variable. So right now 20 will not get cancelled with 40 because A will get cancelled with A. Basically, this you can represent that as A cancelling with A, giving you 0. Like the way A minus A will give you 0. 50, you will take the XOR with it. Then now, as soon as the next 40 comes, 40 XORed with 40 will get cancelled. You can assume it is getting cancelled with each other. Then 20, if you will take a XOR, now is the point that this 20 will get cancelled with this 20. Now, if you will take the XOR with 30, and finally, if you will take the XOR with 50, 50 will get cancelled with 50. Basically, what is XOR? XOR is nothing but if there are different bits, take the answer as 1. If there are same bits, take the answer as 0. That's why 40 and 40 will have same bits. So take the answer as 0 if you do the XOR between them. 20 XOR with 20 will give you the 0 bits. Similarly, 50 with 50. So the only answer which will remain will be 0 XOR 30, or you can say simply 30, because anything XORed with any 0 is always that same thing. So answer will be 30, and that is nothing but the unique number that is not getting cancelled. Why? Because it is not repeating. All the numbers which are repeating will get cancelled. So using this wonderful property of XOR, in how much time will you be able to do it? Since XOR operations are constant operations, we are still running just a single loop over the array. So time complexity will still be linear, as same as the hash map based solution. However, this time you are just creating a variable which is an integer variable, 4 bytes variable usually. So space now is constant. You are not creating any hash map data structure as such. Just a single variable which is going to give you the answer itself. So constant space, linear time, which is even better than the previous one. However, we will not write the code, but the code, if you want to write for this problem, for this solution, will be only 3 to 4 lines. But still, since the problem itself is asking us to do it using hashmap, we will write the instruction manual for the third solution, for the linear time, linear space solution. So what we have to do? First of all, create a hash map. Create a hash map of what? Of keys as integers, because it will be storing the elements, and values are also as integers, and values as integers. Initially it will be empty. What we will do is run a for each loop, for loop, that is up to you how you want to run a loop over the array. Since we don't need the indices in the array, we only need the values in the array. I am running a for each loop. So run a for each loop over the array elements, and what we have to do, put the elements with updated frequency. But in order to do it, first get the old frequency. Get the old frequency of element from hash map, and you have to assume, the note is assume frequency as 0, the old frequency, that is the frequency before updation, as 0 if element does not exist in hash map, if element is not present in hash map. So there might be some internal inbuilt function for your purpose when, let's say, you want to take the default frequency as 0, or even if, let's say, you are just simply picking up the frequency, it might give you 0. Let's say if I talk about C++, if you will just get the frequency of any key which is not present in the hash map, it will by default give you 0 only. But in, let's say, Java, you might have to use a function named as get or default to get the frequency 0 in the case of the key not existing. Otherwise it will give you null value if you will just simply use get function in that. So that's why I've given the note that assume frequency to be 0, not null or not undefined if the key is not present. Once you get the old frequency, now put the pair as the same element, that is key will be element, and what? Value, that is frequency, as the old frequency plus 1, because new frequency will be old plus 1. That is what we were doing. Getting the old frequency, incrementing 1 in it, and put it back. And now the pair as key will be put back, in the hash map. Now, once we are done with the first loop, now what we have to do is run another loop. This time you can run a loop over array, over hash map. It is your choice. I am running a loop over hash map. Run a for each loop over particularly keys of hash map. And what we need to do is check if the value, that is the frequency of that key, of the key, is 1 or not. Because if it is 1, then that is the answer. That key is the answer. If it is, then return the key. Otherwise, if there is no answer present, however, it will never happen that there is no answer present, because in the question it is clearly mentioned that it will always happen that every element will be occurring twice except one element. But still, if it is having such a scenario when there is no single element, what you can do is you can assume you are returning 1 or 0 or -1, anything. So let's just return 0, because in some languages, if you are not returning anything in the last, even if the function is returning or expecting you to return something, it will give you a missing return statement, or you can say the function was not returning anything, error, some kind of error will be there. And in order to get rid of that, we are just returning 0 in the last so that we don't get any error. So this is the pseudocode for the problem find a single number in Java programming language. So in order to use a hash map, we have to create a hash map, obviously, of what? Of key as integer and value as integer. That is the pair of integer comma integer. Key will be the element, value will be the frequency of that element in the array. Let's say hash map name is HM. However, you can name it anything as you want. And better be to give meaningful names. Let's say frequency, FREQ, can be a better name because it is going to give you the frequencies of elements. Now, since you only need the elements, that is the values of the array, not the indices, you need 20, 40, 50, and so on. You don't need 0, 1, 2. What I am doing is, I am running a for each loop. And how to run a for each loop in Java? That is, take the type of element. It is an integer in array. So define integer. Name the variable as anything, let's say element, because it is going to give you the values of the array. Colon, in which array are you running the for each loop? That is, in which array are you always going to get the values from? Not the indices, but the values. So it is int element colon arr. That is the array name. And what we have to do is, we have to just first get the old frequency. And in Java, how to get the old frequency? One function is using get. Just get the element from hash map, hm.get element. But get will give you the answer if the key is present. It will give you the frequency if the hash map exists, or you can say the key exists in the hash map. But if the key doesn't exist in the hash map, then the get function will give you null, because it does not check whether the key is present or not. It will just simply give you null value. So in order to get a default value if the element does not exist, we have to get a zero value. For that, hashmap also provides you another function, which is get or default. And how do you use it? You will say old frequency is nothing but hashmap get function, but with a default value if the key doesn't exist. If the element exists, that is the key exists, get me the value of that key, get me the frequency. However, if we are inserting it for the first time, the old frequency can be assumed 0, so that we can do 0 plus 1 for the very first time. Very first time, the frequency will be put as 1 only. Now what I can do is, I can put the new frequency as what? The element with the old frequency plus 1. You can do it in the same single line also, but that line will become very heavy, very bloated. That's why I have break done in 2 different lines. Now that you are done with the first loop, you know each element, how many times it is occurring. It is present in the hash map. That's why you will run the for each loop over hash map. And you only need the for each loop over keys. So one by one, I will get keys, which is of integer type. You want to write integer, you can write it like this, the wrapper class, or you want to simply write int also, it will work. Both things will work. It will automatically get converted. But since we are only going to run a loop over keys, I will store all the keys in a set. That is, a key set function can be used to get all the keys of the hash map, and we are running a for each loop over all that set of keys. That is, one by one, I will be running a loop in the example over 20, 40, 50, 30 in some order. Obviously, keys, we can't guarantee the order of keys in a hash map. They can be in any random order. So get the keys from the hash map, check what is the frequency of them. And now happily we can use get function, because now we are sure the key exists in the hash map, because we are running the loop over hash map only. So no need to use get or default. Now you can simply use get function. So in the hash map, if the key is having value 1, that is the frequency is 1, it is only occurring for one time, and that element is the answer. So return the key itself. However, if there is no such element, you should have to return something. Otherwise, your Java will give you a missing return statement error. So that's why I'm just returning 0, just for the fact that you get rid of the compilation error. If I will run this code, hopefully it should run. Let's see. The code is not big, but it is a very important problem in terms of understanding the map-based solutions. So there is certain symbol which is hash map, which we are not able to get because we have wrote hash map with h small. It is not h small, but h and m should be capital in hash map. In the left hand side, you can only write map. On the right hand side, you should have to write, or you must have to write hash map only. So it is working fine for sample test case. I am not discussing various corner scenarios. I'm just taking one bigger test case having values, let's say 40, 50, 60. Then let's say 30, 30, 60. And let's say 40 is unique, or maybe not 40. Let's take the 60 to be unique, and 40 should be repeated. 1, 2, 3, 4, 5, 6, 7. So there are 7 elements in total. Let's just see. Hopefully it should give me the answer as the 60 element. I guess 60 was not repeating. Let's see. It was either 60 or 50. I'm not sure. Yes, it was 60 only. So it will work for all kind of test cases. Hopefully, let's just submit and wait for the current code. It is a previous submission which is being displayed right now, but the current submission is also working for all the corner cases. So even if there is only two elements, or actually only one element in the array, not two elements, but only one element, that will be the answer. Our code is still going to work for that. You can do a try run. And even if there are a lot of elements, the maximum number of elements according to the constraint, it will still work. And the code will still work for negative elements. So I think we should wrap this problem with this video at this moment. We will come up with a new video with a new problem. Till then, bye bye. Take care.